no noise, and workers remain virtually invisible. Right before your eyes, such a magnificent structure gradually diminishes until it vanishes completely. This is Japan's world-renowned stealth demolition method. While other countries still employ conventional demolition method, Japan has pioneered this advanced technique. This 40-story Tokyo skyscraper is currently undergoing demolition to avoid disturbing nearby residents and prevent environmental damage. Contractors erected a 3-story high scaffold enclosure. Its exterior is fully soundproof, with 15 rigid structural columns per floor providing support, enabling interior worker operation once demolition commences. Workers systematically dismantle each floor step reinforced concrete and structure. Hydraulic jacks lower the scaffold, 1 level per dismantled floor, simultaneously descending the support structure. The process repeats identically for subsequent levels, progressing as smoothly as a Tetris game. An entire building seemingly vanishes within remarkably short time, unlike conventional explosive demolition. This method operates in complete silence, without impacting surrounding residents. The trade-off is extended duration, where explosive demolition takes near days. This meticulous process requires months to dismantle a building quietly. In a desert so harsh, even camels lose hope. Before us stretches the Taklamakan Desert, 330.000 square kilometers of shifting sands in China. Sub-Saharan Basin, Qinghai, is China's largest deserts, and the world's second largest shifting desert. Its barren expanse hold scant vegetation and profound isolation. Sandstorms periodically rain, burying everything in their path. No wonder it's all earned another name. A place where death feels near. Building a highway here. The difficulty beyond imagination. The builder's motivation. Wasn't she reckless extravagant? But the discovery of rich oil and gas reserves deep within the desert. These precious human resources demanded access through this hostile environment where no direct route existed. Alternative paths would consume excessive manpower and material, hence the bold decision to construct a highway piercing the desert's heart for efficient resource transportation. But desert highway construction poses unique challenges. Engineers first confronted how to construct a stable foundation in shifting sand. Initially, engineers experimented with countless approaches, all ending in failure. As budgets dwindled, frustration mounted after exhaustive trial. They devised an ingenious solution: compacting the sand, laying synthetic geotextile fabric, topping with desert mined gravel, and compacting with asphalt. This multi-stage process instantly stabilized the shifting substrate, while maximizing local material, drastically cutting costs. With this breakthrough, construction accelerated, but deep in the desert, new challenges emerged. The rock-crossed populous Euphratica forest, where soil conditions deteriorated dramatically. Fine alien soil, bone dry and unstable. Defy conventional stabilization. Previous techniques failed completely. What now? Abandon the hard-won progress. Engineers brainstormed and innovated. First, widen the subgrade base, trenching along the roadway alignment, then burn the shoulders to contain loose material. Layered laterite and gravel were saturated, compacted, then paved, creating rock-solid foundation. Ingeniously, the desert highway's solid foundation is now complete. Yet this marks only the beginning of the endeavor. The Taklamakan Desert hellish environment poses a constant threat of sand erosion even after completion. Engineers anticipated this challenge from the start. These reed and straw grids serve as ingenious sand barrier, reinforced by woven reed walls along the perimeter. They effectively shield against desert wind. What's more crucial is planting desert hardy vegetation along the roadside to anchor shifting sand. Road construction alone isn't sufficient. Greening the desert and ongoing maintenance make this a truly daunting mission. Throughout this ordeal, the construction crews endured extreme hardship, battling water scarcity and food shortages with barely habitable conditions. They fought loneliness and uncertainty daily against all odds in this hostile land. They carved this arrow straight highway, an achievement beyond imagination. Our deepest respect for these pioneers. On Tibet's 5.00 M cliff, drones capture this shocking scene. An excavator operating on sheer rock faces, above endless abyss and raging river, where danger lurks constantly. The barren mountain show no vegetation, only rocks and howling winds. Landslides could bring catastrophic consequences. A wrong move plunges workers into fatal abyss. Operating here makes life hang by a thread. Just watching these scenes is enough to terrify ordinary people. Is this even construction? This is a high-altitude death-defying act. This is the construction of China's Sendai Cliff Skyway, located in Baksoi County, Kommendo City, Tibet Autonomous Region, with its treacherous terrain and numerous hairpin turns. This is famously known as the Nujian 72 hairpin bend. Aerial views reveal its perilous winding path through steep mountains, guaranteed to make your heart race and break you out in cold sweat. This gives you an idea of the hellish difficulty in constructing this mountain road and cutting through the terrain. Typically, altitudes above 3.00 meter cause severe altitude sickness in ordinary people with symptoms like labored breathing, chest tightness, and headache, making prolonged work impossible. Even if workers overcome physical challenges, they face an even deadlier psychological terror. Endless valleys, raging rivers, and biting winds make every step perilous, where survival itself is uncertain, let alone operating excavators. That's why those who operate excavators on near vertical cliffs are true masters of their craft. This marvel showcases China's infrastructure prowess and embodies the courage of workers battling extreme conditions. As vehicles slowly navigate the Nujian 72 hairpin bends,